Identify the compound that is a constitutional isomer of the compound shown below. So we want to make sure that we know what a constitutional isomer is. So the term isomer in general means that the two molecules have the same formula but are not the same. They have a difference in some way. And then we have different types of isomers. So a constitutional isomer, we're talking about molecules that have the same molecular formula and they have a different connectivity. So that has to do with how the atoms are connected together. So maybe one has a parent chain that is longer than the other because they're branched differently, or maybe the substituents are on different carbons, stuff like that. So to check for constitutional isomers, the best thing to do would be to number your molecules as though you're going to do the IUPAC name. So if we are looking at this molecule, our longest carbon chain is 4 carbon atoms. The substituents are chlorine and fluorine. And no matter which way you number this, you're going to see substituents at carbons 2 and 3, or if you go the other way, 2 and 3. So in this case, we would use alphabetical as our tiebreaker. So we're going to give the chlorine the lower number. So this isn't a rule that chlorine gets priority. This is a case where either way we do it, we're going to get the same set of numbers. So we need a tiebreaker, so we go alphabetical. Okay, so we can see that. So that tells us that the base part of this name, ignoring stereochemistry, I'm not going to bother with stereochemistry because we're not looking for stereoisomers, we're looking for constitutional isomers. So this is 2-chloro, 3-fluoro, butane. And if you were looking for a stereoisomer, then you'd have your stereo centers, you'd list those out in front with a designation for each of them, whether they're R or acid, carbons 2 and 3. But if we're looking for constitutional isomers, we're looking for something that doesn't have this as the main part of the name, and that would indicate that they're connected together differently. So if we look at A and we number the chain in the way that we would for IUPAC nomenclature, we can see that this is also 2-chloro, 3-fluoro, butane. Okay, so that is definitely not a constitutional isomer. It might be the same, it might be a stereoisomer, but it's definitely not a constitutional isomer, so I'm not going to spend any more time with that. We'll do the same thing with this third one, and this is also 2-chloro, 3-fluorobutane. If we look at C, this is also 2-chloro, 3-fluorobutanes. We have not found constitutional isomers, so it's got to be here in D. And we can see here we've moved things around. The chlorine and the fluorine are attached to the same carbon atom. So that is what makes this a constitutional isomer. So if we gave this one a name, it is 2-chloro, 2-fluorobutane. Right, so you've got a difference in connectivity will show up in the name. It'll show up in a different parent chain, maybe different substituents or different numbers where those substituents are. Okay, and if you wanted to go through this a little bit more thoroughly, we could kind of go through and say what the relationship for all of these are. So B is clearly the same molecule. We can see that this is essentially a cut and paste. If we look at A is also the same molecule. It may not look like it, but you can imagine if you take this and rotate it within the plane of the paper 190 degrees, you're going to end up with the same structure A. So that is also the same molecule. And you can prove that to yourself by assigning the R and S stereo centers, and you'll see that they're the same. And then we can see in C that this is definitely not a mirror image because you've got the fluorine and chlorine on opposite sides in this conformation, and they were on the same side in that starting material. So this means that this is a stereoisomer that is not a mirror image. So C is a diastereomer. Okay, but we were asked for constitutional isomers, so I guess we should actually circle the right answer, and that was D.